welcome to Master Kubernetes. In this course, we'll explore Kubernetes, the leading package in one of the most exciting and lucrative areas of computing technology today, container orchestration and deployment. We'll focus on hands-on learning, but first, let's explore the trends that have given rise to containers, the need for container orchestration, and how that has created the space for Kubernetes to rise to dominance and growth. The growth of technology into every aspect of our lives and days has created immense demand on software. The companies and organizations that sell and deliver products based on software or just use software in their businesses. This really is nearly any business and anyone who doesn't live entirely off the grid. This pressure has spurred innovation and standardization, and the needs and stakes are so high, it has fundamentally changed how software is developed and deployed into production. But this evolution isn't without precedent. Could you imagine the world's economy relying on methods like this for the trade of goods? There would be no way you'd get your new iPhone in time. Now we take it for granted that shipping containers efficiently move between different modes of transportation, different ship owners and shipping companies, and they've standardized, ubiquitous, and available anywhere in the world. Almost always, no matter what it's in, if it fits, it ships. Modern software is becoming quite similar. As software systems become more complicated, this complication has driven software to be divided into smaller pieces such as microservices. Whether they're called microservices or not, these smaller pieces of software each need to be packaged, built, deployed, and accessed by other pieces of software around them to function as a total system. These small pieces of software can be deployed into containers that allow them to run on the same machine, virtual or real, but making it appear to the software that it's the only process running. Here's where we depart from the shipping container metaphor a bit. While a shipping container's sole job is to keep things contained within itself, typically interesting and useful software depends on other software around it to do its job. Here is where the need for container orchestration is born. There are definite benefits in keeping logically distinct software separate from each other. You can develop, deploy, scale, and maintain each small piece without too much fuss between the other parts of the system when it's not all in the same module. However, at some point, different parts of your application likely need to communicate with each other to do something interesting. For example, an API may need to communicate with business logic. It needs, in turn, to access information in a database. Containers themselves keep logically distinct pieces of software separate so they can be built, deployed, maintained, managed, and scaled on their own without unduly affecting other parts of the system. Container orchestration, on the other hand, defines how these containers interact as a system, the needs between each other, and how they come together to a performant, manageable, reliable, and scalable system. It is currently safe to say that Docker is the dominant leader in both technology and in adoption in containers. While others exist in the space, their dominance is so great, when you mention containers, it is almost synonymous with Docker. Other players exist in niche applications, and some movement around standardization is occurring. Although is nascent, the Docker file standard is essentially today's standard, and Docker repositories define the dominant way of hosting versions of a container between developers and between systems that need to use them, such as orchestration systems like Kubernetes. Since container orchestration is a much newer space, only growing since the adoption of containers, the technologies are newer and still evolving. However, Kubernetes is quite advanced, and with Amazon Web Services finally joining its competitors in embracing Kubernetes, it now has the backing of nearly every major player in cloud computing through the Cloud Native Computing Foundation, also known as the CNCF, the organization that now governs Kubernetes. It has essentially become the de facto standard, especially now that it's nearing alternative or competing technology, Docker Swarm. Docker's solution to container orchestration has now announced support for Kubernetes-style configuration and processing. It is clear that Kubernetes is now the de facto standard, if not the acknowledged standard, in the industry in container orchestration. Containerization changed how software was developed and packaged. Container orchestration is changing how containers are deployed into bigger useful systems. From here on out, we'll focus on how to use Kubernetes as your framework for container management using Docker containers. In the next lecture, we'll focus on the growth, lineage of, and why the market has chosen Kubernetes.